My name is Johan Herland. I work for Cisco in Norway doing video conferencing. This is not going to be about video conferencing at all. This is going to be about Python. I do a fair bit of Python programming at work, and this is one of the nice little modules that I've discovered in Python 3, and I thought I'd tell you about it. So I'm just going to assume that you have some basic Python familiarity. And sort of a little disclaimer up front, pathlib, the subject of this talk, is provisionally included since Python version 3.4. So it's quite recent. Provisionally basically means that there's still room for backward incompatible changes to pathlib. So yeah, things might change, but it seems that the API has stabilized somewhat, and I think it looks pretty nice as is. Where things have been added post version 3.4, I will note so in my slides, but otherwise this is all available in 3.4. If you're not so fortunate as to be working with Python 3.4, there is a separate standalone module, pathlib module, that you can basically download using pep or easy install for Python version 2.6 through 3.3. So in short, I'm just going to talk about what pathlib is, why would you want to use it, and give you a couple of examples, a quick overview of the API, or at least the most common parts of the API. And then finally, I'm going to talk about some remaining issues with the module. So what is pathlib? Well, in Python, path names are traditionally like you use strings to represent file system paths. You pass a string to open, you pass a string to the various OS functions. What pathlib does is represent them as proper first-class objects, where you can actually query the path by its properties. These are, like strings, immutable or value objects. It's not like you can modify a path object in place, make it refer to some other path. What you then get is another different path object. Pathlib, as Python is pretty good at this already, but pathlib even more handles platform differences very transparently. You can write simple code that works well on both Unix and Windows. And in addition, it offers a rich API for various attributes of paths and working with them. And basically, it replaces, or it doesn't replace in that these things go away, but it sort of supersedes a bunch of things from the OS path module, from the OS module in general, and a few other things. What is pathlib not? Well, it only handles the paths themselves. What happens to a file after you open it is still a regular Python file object from that point. Pathlib is really about just manipulating paths. And it doesn't handle other path-like things like URLs and so on. So why would you want to use it? Basically, it gives you somewhat easier and somewhat safer handling of path names. In general, I would say that the best argument for using pathlib is that your code gets somewhat more readable. You get less of the os.path.something function calls in your code. As you can see down here, something like what we're doing here is we're checking if path is a directory, then we want to remove that directory. Instead of getting os.path in front of all the function calls, you get a code that looks more like this, where you basically query the path. If the path is a directory, then you RMDir that path. So a typical scenario where pathlib would be very useful is when you're working in, for example, a build or a packaging system, or a glue code scenario where Python is often used, where you sort of piece together different parts of a system to make it a whole coherent system work together. Typically a scenario where you do lots of path manipulation, like creating and moving directories, moving paths around, so on. So a little more in-depth example here. Let's look at the top code first. This is sort of before a rewrite to pathlib. What we're doing here is we have a function. I'm just calling it maybe generate data. It's a function that takes a path, and then it writes a lot of data to that path, except that if it figures that nothing has changed since the last build or since the last time you ran this, then it ends up writing nothing to that path. It basically generates an empty file. So what you want to do is you want to call that function, but if it ends up writing nothing to the file, you would rather retain the previous version of the file than using the new empty version, because the empty version isn't worth anything. So what we do here is we create a path. Out path is where we want to store the data finally. And we basically do that by joining the current working directory with this file name, my output. But we don't want to write directly to that, because in case we end up writing an empty file, we would lose the old version. So we create the temp version as well, and then we write to the temp version. And then we ask, OK, if the temp version has a size, basically is non-empty, then we end up renaming the temp version into place. Otherwise, we just remove the temp version, the empty file. So we retain the old version. So there's a lot of path function going on here. We join some paths at the top with the current working directory. We ask for a path or the size of a file. We rename and remove. When you rewrite this pathlib, basically the os.getCwd becomes the paths.cwd function. Instead of using os_path_join, you basically use the division operator or slash operator to join paths together. And then we call the function with the same parameter. And then we ask for the paths, stat information, and query its size. And if it's non-empty, then we rename. We take that path and we rename it to the output path. Else we just unlink the temporary path. So what happens here in general is that the variables of interest, where you basically want to keep your focus, moves from being arguments on the right-hand side of these os_path functions to the left-hand side and becoming the sort of active or the actor part of your code. So I find that when I read this code, the objects of interest, the variables, are at the left-hand side easier, or where my focus is better, rather than pushed out to the right as arguments. So, quick overview of the pathlib API. Creating a path object, you can just take a regular path string and wrap it with a path constructor. Or you can start creating paths from some of the factory methods on the path class itself. So path.cwd gives you the path for the current working directory. Since Python 3.5, you have path.home, which gives you the path to your home directory. And then, as I said, you have this slash operator that joins paths together. It replaces os_path_join. And you can use it on path objects. So a path object slash another path object does what you think. It also works with strings, both before and after the slash. However, it does not work with strings on both sides. Basically, what Python sees here is, oh, you're trying to divide one string by another string. That doesn't make sense. All of these cases, remember, you always return a new path object. So when you take one path slash another one, you cannot rewrite an existing path because they are, as I said, immutable value objects. Paths have very simple attributes that are very useful. So you can ask a path for its dot parts, and then you basically get the various parts of the path. You can ask for its parents, and then it basically ends up generating the parent directories all the way up to the root. And you can ask for its dot parent directly to get its immediate parent. So this replaces os_path_dir name. You can ask for its name, which is equivalent to os_path base name, or its suffix, which if it has multiple suffixes, so let's say a .tar.gz file, you can use dot suffixes to get a list of its suffixes. The .stem returns the part before the first suffix. Often, especially in build systems, some commands require you to give them absolute path names. Other works better with relative path names. You can use the .isAbsolute query method to basically query a path, whether it's an absolute path or relative path. You can use .resolve to turn a relative path, so in this case documents, into an absolute path. So basically it prepends the current working directory. And you can take an absolute path and make it relative to some directory. So basically here I have this absolute path. I want to make it relative to /home, so I get back the relative component. More replacements for OS path functions. You have, for a path P, you can just ask .exists instead of OS path exists. You have the is there is file is symlink as you have in OS path. Since version 3.5, you also have expand user, where you can expand a tilde expansion like you can for OS path expand user. And you also have .same file. So say you have two links to the same actual inode on disk to two paths that refer to the same file. You can ask p.same file and then another path to basically return whether or not they actually refer to the same inode, the same file contents. For the OS module, there are a bunch of replacements there as well. chmod, iterdir replaces lister, mkdir, rename, rmdir, stat. Symlink2, which I find is a much more intuitive way of using the Symlink API rather than os.symlink. So basically here I say that I want to make p a symlink to this file. In Symlink, I think it takes the arguments the other way, so you would first name the target of the symlink, then the name of the new symlink. Yeah. There are some other convenience functions in the path API as well. p.match replaces simple file name matching that you find in the fnmatch module. p.glove does the same, where it actually goes onto the file system and searches for matching files. So you can say, okay, give me all the star.py files in this directory or something. And p.open. p.open is a nice convenience instead of using open with paths. I'll come to why using open with paths is problematic on the next slides. But you would use it, for example, like here. I have an input path. I open that one as my input file object. I have an output path. I open that in write mode as my output file object. And then for each line in the input file, I write it to the output file, filtered through some process. Yeah. And in Python 3.5, there's even more convenience. So if you're just reading or writing a very short file, where you would just file.open, then .read to read the whole thing in and then close it again, you can just do .read bytes or read text for reading in text mode, and the same for write directly from the path object. So some of the issues with paths. It's, as I said, still included on a provisional basis, so there might be changes coming, although I can't see any big changes happening right now. It does, however, miss a certain amount of integration with the other standard lib modules. So when you use these other modules, like open, you can't pass it a path directly. Instead, what you need is basically to turn that path back into a string, and that's basically just simply that's simply wrapping it in a stir function. So basically, if you stir a path, then you get the string representation, and you can pass that to all these. However, it takes a certain amount of busy work to just wrap your path objects in stir wherever you need to pass it to a legacy API. Yeah, so here are some techniques for combining pathlib with legacy code. For example, shutil functions are some of those that still only work with strings. So you would just take your path object, wrap it in stir. Since Python version 3.4.5 or 3.5.2, you can also use the .path attribute of the path object itself, which also returns a string. And then if you write an API that takes a string and you want to make it into a path, you just wrap it in the path constructor. And there's this construct here for taking a path or a string and turning it back into a string. So that's sort of agnostic of whether you're given a path object or a string. There's some stuff missing from pathlib. I would like to see an os.walk function. I would also like to see some integration with os.scander, which does more efficient traversal of the directory structure. There are also some niggles where, say I have a .tar path and I want to append a .gset to that. I haven't found a really nice way of doing that. Maybe the bottom one here is the best one. But yeah. And there might be more things missing that I haven't encountered yet. Here are some links for learning more about pathlibs. The documentation in the standard library is quite good. There's the PEP 428, which sort of goes through the rationale of why we want pathlib, includes it, why we want to include in standard lib, so forth. And at the bottom there is a link to the pathlib version for older Python versions. So yeah.
1 minute for questions.
Yeah.
Okay.
Okay.